Hello, welcome. This is the next Edexcel D1 tutorial kind of thing. Okay, so in this video we're going to be looking at matching. Now I've put a diagram, a graph on the board here, which we're going to use. Obviously you'll be able to understand it later on, but that's just to get you thinking of what we're going to be doing. It's a type of matching. It's called I personally call it a data matching. Okay, so essentially matching is all about where we've got one set of nodes here and we've got another set of nodes here. So in this case it's a different worker A, B, C, D, E, and these are nights, okay, Monday, Tuesday, Wednesday, Thursday for the respective nights, and they're being asked to work overtime, okay, and this shows what they can do. So the lines coming from A, okay, show that A can do Monday or Wednesday night, okay, and B can do Monday, Wednesday and Friday, C can just do Monday night, whereas D can do Tuesday, Wednesday, Thursday night, and E can do Wednesday and Thursday. And this graph is just showing that. Now, the reason they're not connected on either side, well, you think about the terms of what we're saying here. A is just a work, it can't be connected to B, it can't do B, well, that'd be weird, a bit weird. So it can only do Monday or Wednesday night, it can't work B, it doesn't make any sense, okay? So therefore, we can't connect one node, so we call this a set of nodes, so A, B, C, this is a set, and this is another set, okay? And this is called a bipartite graph, where we have two sets of nodes, okay? Where you can't connect one node to another node in the same set. In other words, you can't connect A to B, you can only connect A to one on the other side. Okay, and what you'll be given in the exam, you'll be given as data that says A can work, one node can connect with a number of different nodes on the other side, such as A can work Monday or Wednesday night. So this is just a data representation of that on a bipartite graph, which, remember, is just what we said of one set of nodes and another set of nodes that we can connect, okay? And this is the first thing you do, and generally it will tell you, okay, it will tell you the data matching. But you just literally, it just says, just draw, illustrating what it says in the table on a graph, so you can see and you don't have to keep looking back to it, okay? And then what you'll be asked to do is suggest, well, what nights should each worker work? Because the problem may say, such as this question does, it says each worker has to, each night has to have a worker working on it, if it makes sense. So it needs one worker working each individual night. But some workers can only work one night, like C can only work on a Monday night. So you could work it out logically by just deducing by observation, just simply looking at it, go, well, obviously C can only work Monday night, so that worker has to work Monday night, but A's got a few options. As it can only work Monday or Wednesday, because C is working Monday night, there's no point two workers working on one night, we need to spread it out, okay, so A therefore must work on Wednesday night. And you could do it like that by just simply working it, and then you could go, oh, well, E's already working on, E could work on, because, okay, well, look, who else can work on Wednesday? Well, this E. E can only work Wednesday or Thursday, so therefore E must work on Thursday, because we said A is working on Wednesday. And essentially what this matching is doing is representing what we're saying there, going through it logically, but in an algorithm, okay, which is just a series of steps. And what I'm going to be doing is just showing you how we can work that problem out of each night must have one worker on the shift, on the tills or whatever it might be. I mean, it's night, so what jobs people do at nights, I don't know. It's out on the streets in darkened corners. Anyway, what I'm going to be doing is just going through this kind of typical problem, and then for any matching graph, I'm going to give you a set of steps, okay, that you can follow that will answer any problem which uses a matching, okay, and ask you to complete a complete matching. Now, the next thing that they will tell you is something called an initial matching, which just involves you drawing this graph again. I think it's probably drawn for you in the exam. Okay, yeah. But they will always tell you this initial matching. And you go, what is the hell is an initial matching? Well, this is what they could do, okay? But the initial matching is generally some manager or someone coming up with an idea of what could happen. Okay? And you just have to illustrate that on this initial matching graph. And in the case of this question, they've said, so let me just find it. They've said that A might work on Monday night, so you connect A with Monday. Probably should have done that in blue, but never mind. So they've said A could work on Monday. Now this is not definite, can change. Okay. B will work on Wednesday. Okay. It says D on Thursday. So it hasn't connected C or E. Now you could go, well, C goes with Tuesday, E goes with Friday. Well, no, because to be able to finish this initial matching, we need to look at, well, what can C go with? Because it can't, if we look over here, it can't go with Tuesday. This data matching, the reason we've drawn it is to show what possibilities can the nodes on the left-hand side possibly have, okay? Because we need to connect them up with something. Alright, so we need to connect C and E to nodes, okay? And you have to be able to do that, we have to look, well, on the left hand, on the data matching, what possibilities are there for these unmatched nodes on the left hand side? Because we need to connect them all up. And it might involve moving one of these. It will, because we have to pick one that is already connected on this initial matching. So for C, we could either pick the Monday, Wednesday or Thursday. Obviously we look on here which ones C is connected with. Because if we didn't connect it with one that wasn't already connected, we wouldn't increase our matching. In other words, we'd just be adding one more. We won't be increasing the matching. And what we mean by that is we won't be able to go in this cycle, in this algorithm. It wouldn't allow us to follow this algorithm if we didn't pick a C to connect to a node, which is already suggested in this initial matching. Okay, so we look at C and we say, well, quite clearly C can only go with Monday. So what we have to do is write this little sort of mathematical wording. So we'll say C connects with Monday, and you do that by C little hyphen dash thing M. But you say, well, M was already connected, and you put equal sign for saying M is already connected with A. And then you put a little dash, you're saying what you want A to be now connected with. Well, you go back to A, and we look at A. Well, A is either connected with Monday or Wednesday, but you've already picked Monday for C. Okay, so you can't pick Monday. So therefore, as A's only option is now Wednesday, you pick Wednesday, so you put Wednesday. But then you look at Wednesday. Well, that was connected with B, so you do a little equal sign, say that was connected with B. But you look at B and you go, well, B can connected with Monday, Wednesday or Friday. Well, we've already picked Monday in the first set to go with C. We've already picked Wednesday to be reconnected with A, okay? So therefore the only option left for B is Friday, so we do a little dash for Friday. And there was nothing else connected on this for Friday, so we can stop there. And then what we do is we change the little dashes with the equals to say they are now connected. So C is now connected with M, and then little dashes where there was an equal sign. And then we say A is now connected with Wednesday, B is now connected with Friday. So that's the kind of thing you need to say in terms of mathematical wording. So hopefully that makes some kind of sense. So what you would do now is, so it's up to you if you want to draw another graph. I can just rub these off. So we said that C was now connected with Monday. Okay, so you can follow this. So C was now connected with Monday, so we draw a line to Monday. But we said that was connected with A, so we need to replace A with something else. Then we said A was now connected with Wednesday. Okay, but then we said, well, B was connected with Wednesday before, so we need to connect it with something else. So the only other option was Friday, so we connect B with Friday. Okay, but we've still got another possibility there. We've still got to work out what this node E goes with. Now we look at the node E, and that's either being able to connect with Wednesday or Thursday. Okay, now there's no point choosing Wednesday because we already know from the fact that A can only go with Monday or Wednesday, and if we chose Wednesday to go with E, then we'd have to rearrange A, we'd be doing this all again. Okay, so don't pick one that you've already used in your first part of, this is going on to the complete matching now, by the way. Yeah, so anyway, Yeah, so therefore, our only other option for E is Thursday. So you start a new line and you put E, we want to connect that with Thursday. So put T. But Thursday was already connected with D. So you put equal to D. And then you do a little dash and say, we want D to be connected with, well, the only other option is Tuesday or Thursday. And Tuesday's currently got nothing attached, so we can put Tuesday. Okay, and then do the same thing again. Change the little dashes into equals. So the worker A is now working on Thursday. Okay, and D is now working on Tuesday. Okay, so you apply that in now. So E is working now on Thursday. Therefore D is no longer working on Thursday, and therefore D must work on the Tuesday. Okay, so that would be a common problem. Now, I can kind of rub the initial matching off here and drawn this other completely different suggestion here. And then what you would obviously do is just label what you've got. So you say, well, A is on Wednesday, B, well, that works on Friday, C works on Monday, D works on Tuesday. Sorry, I should put these in. And E works on Thursday. And you should see from that every day has a worker working on that day. Now I've picked this one. There's a couple of things that I want to point out. The first one of which is the fact that I suggested the initial matching, what the manager initially suggested, and then I just kind of rubbed it all off. This would be a separate graph. So in other words, you would now have three graphs, this being your third, and the second being your initial matching. That's what you'd put as your first. Okay, now I've said that A works on Wednesday, B works on Friday, C works on Monday, D works on Tuesday, and E works on Thursday. But depending on which one you picked, okay, you might have started with connecting C to another day. Okay, that meant therefore obviously this completely would have changed. So your answer's going to be right as long as obviously you end up with a day with each night has a worker working on that. Okay, so you might have got a different set of answers to me there, but it doesn't matter. So if you get an answer, you get a set of answers and the mark scheme says a different thing on your homework or whatever you're doing, it's all right as long as your method is correct and obviously it works in terms of the answer works. You've got, in this case, you'd have a worker working. You'd have a night where a worker is working at least once. Okay. All right. So hopefully that makes some kind of sense. Now, the different questions, and this question in particular, they did break it up. So the first part of this question, they said, draw a Bipartite graph for the availability of the 5. Okay, so that data matching is what you draw for that. B says, obtain an alternative path starting at C and use this to improve the final matching. Okay, so for that, you would simply write. So basically, we've done 2 steps in this here. We did the node for C, okay, and we worked that out, and that followed kind of some principle that repeated itself, okay, because we connected C with M with Monday, but A was already connected with Monday. So basically, what we've done here is we've had 2 nodes that we've not that are not connected in the initial matching, okay. And what you do is you start with one of the unconnected nodes, okay. And you connect that with, you look back at the data matching, okay, well what can we connect that with? And then look at the ones that are already chosen in the initial matching, okay, and say, well, we need to connect C with Monday, but A was connected with Monday, so we need to replace A with something else, connect A with something else, sorry, and then repeat that until you don't go any further. In other words, you've moved everything and you can't replace anything else. In terms of you'll get A and you connect it with something that isn't already connected with something else, okay, and then you stop, and then you do the second node, okay, and repeat that, connect, you look back at the data matching, see, well in the case the other unknown node was E, and you look back at the data matching and say, well what can we connect E with, and then go, well we connect E with Wednesday or Thursday, and then look at the ones that haven't yet been altered, okay, in your wording, okay, because obviously we hadn't altered Thursday, so we chose Thursday, and therefore, because Thursday was connected with D, we had to reconnect D with something else. So the only other option that we looked back at the data matching for D was Tuesday, so therefore we connected D with Tuesday. Okay, so hopefully that's quite a simple principle now. I didn't want to drag it on too long because I think kind of crux of it are there. But I'll just do a little bit of a recap on this, kind of a three-pointer, if you will. So the first thing that you will do is draw the data matching, and hopefully you know by now that just means a bipartite graph which represents the data. Okay. Part 2 is draw the initial matching, which is what the manager or whoever suggests, and it will always be told. Okay, so the first 2 steps are very, very easy. The third step, you could technically break it down to however many unknown nodes you have. So you would start at an unconnected node. I'm just going to connect this. I'm going to continue this explanation on the right hand side of the board. I don't have enough room. So you would start at an unconnected node, and then you would look, okay, at the data matching. So by looking at the data matching, okay, choose a node to connect with. And this node, remember, has to be already chosen on the initial matching, okay, to connect with. And then, if needed to, which you most commonly will, replace the node that it was originally connected with, because what that means essentially is, because we had to connect C with Monday, okay, because there's no other option, A was already connected with Monday, so we need to replace, we need to reconnect A with something else. So that's what I'm saying, meaning here by if needed to, replace the node that was already connected. And then you would just repeat that process, okay, for any other nodes that you would need to. Okay, so by that I mean you would continue that until you don't do any more, and then when you've done that, you will repeat step 3 for the other, however many other unconnected nodes that you might have. Okay, so hopefully that explains just a little bit about this. So it's nothing too difficult. It's more just the theory of trying to understand what to do is the more difficult bit. Actually doing it, once you get the hang of it, is very, very easy. I think the main thing with this is repeating, because all the questions are, the method's similar. I mean, obviously the topic is the same, so the method is going to be similar. Just obviously they give different scenarios, okay? But the principle stands: you draw the data matching, draw the initial matching, which is told, and then you alter this. You have to draw these little symbol things, okay? To enable you to choose the next set. Okay, so thanks for watching. Just give you a second if you did want to copy any of that down. Okay, so thanks for watching. Hopefully it's been helpful, and we'll see you in the next video.